This is my game, and my game currently has this low poly terrain that you can see here. But can I be honest with you, it's kinda boring. I want to also have blocks in my game so that you can build stuff with them. And while we're at it, the terrain also seems kind of bland. Let's add some objects to that. Sounds simple, right? Well, it really kind of wasn't. The first big issue that already came up when conceptualizing is that it's going to be really slow and complicated to get all that under the hood of a single system. It would have to differentiate between the multiple types of voxels and manage the mesh generation for all these vastly different concepts. So what could I do instead? Three completely contrasting concepts with vastly different needs. What if I actually made three separate systems? Obviously, there are still huge issues with just running three separate voxel engines in a single game. To illustrate, let's say a player joins a world. All three systems then have to firstly figure out what chunks to even load, then keep track of all the players that joined the world, and also figure out when to unload old chunks that aren't needed anymore. All of which get progressively more demanding the more players are in the game. Furthermore, if a player tries to interact with one of the systems, I'd need to check every single one to figure out which voxel system should actually react to that in what way. All this together would create severe performance overhead and make it really difficult and ugly to manage in the codebase. Long story short, it wouldn't actually make sense to make three completely separate and independent systems. So for once I actually won't. Instead, what I came up with is a generalized chunk management system with one central chunk manager that does all the chunk loading calculations, player management, and that also provides centralized and generalized functions to interface with all the sub-managers. This also allows me to easily create new sub-managers that just slot into the system, which could even be done through mods. Let's now take a closer look at the workings of the chunk loading within this system. The central manager provides this function that allows me to register a new chunk loading ticket, which consists of a certain volume of chunks and a duration that those chunks should stay loaded for. It then checks whether an identical ticket already exists, in which case it just updates the duration time of that ticket. If it doesn't find an existing ticket, it adds a new one and marks these two flags, which I'll get to in a bit. First, we loop over all the chunks affected by the ticket and add them to a per chunk map, keeping track of the state of every single chunk. I do also maintain an additional map here for every loaded chunk column, so every x and y coordinate containing a loaded chunk, which I split up like this to save a bit on hash map lookups. In the tick function, which currently is executed 32 times a second, I firstly make sure that every player has their loaded chunks. I then run this function which updates all the timers of the chunk loading tickets, removes any that have timed out, and returns a boolean that indicates whether any have actually been removed. If any have indeed been removed, or if any have been newly added, which is where this flag I talked about earlier comes into play, this function is executed, which unfortunately gets a little more complicated. But I'll try my best to give you a quick overview. I start by getting all the tickets that currently exist. By then iterating over all the loaded chunk positions, I can calculate which of the tickets puts each chunk in the highest loading state. For reference, there are 7 possible loading states in total if you count not loaded as a state. All the chunks whose loading state differs from the state they had before the updated tickets are then collected in one of these two arrays, which, by the way, all of this is also evaluated for every chunk column. The in total 4 resulting arrays are then used to tell the submanagers about all the chunks that might need to be updated. For the perfect example, let's take a look at the terrain manager, which is responsible for creating all these chunks that exist so far. Here in the chunk update function, I just iterate over the updated chunks, get the terrain state object for each chunk, which contains information about things like, for example, the state of the mesh generation, and now I can really efficiently check what needs to be done with each chunk. Obviously, if it's a new previously unloaded chunk, I'll have to first set it up. But then, depending on the new and old loading state, I can start to load in the voxel data for the chunk or kick off the mesh generation in its separate thread. But I already showed you all that in this video, so I'm not going to go over that again here. The end result, I'd say, works pretty damn well, which also means that that's 1 of 3 done. Thankfully, the next 2 are going to be much easier though, now that the framework is all set up. Alright, let's get right to it then, the block manager. In the chunk update function we have a very similar structure of course, it is going to be a bit simpler here though. Since blocks will for now really just be used for building, there isn't any need for generating their voxel data or anything like that. Additionally, I will keep the meshing algorithm really simple and even just use an instanced static mesh component to place in block meshes. Main reason is that I saw that they made a bunch of improvements and additions to the instanced static mesh component, which I don't yet have since I'm still on Unreal Engine 5.2, but I really want to give them a try. Which also means that it's definitely time to update soon and revisit this implementation, so keep an eye out for a video on that. In general, it also just makes sense to not overcomplicate this. I really don't expect too many blocks in a normal chunk. Which is also why I decided to go for a completely different voxel data structure compared to the terrain. The blocks for each chunk are stored in a map with the local in-chunk position as the key. For this I even made my own memory efficient vector data type that supports 5-bit unsigned integers in every axis, which is perfect for chunks with 32 blocks aside. It ends up using just 16 bits compared to the 192 bits a default integer vector would use. Does that actually have a meaningful impact? Probably not, but I did it anyways. Back to the meshes though, when the block manager receives a chunk update that moves a chunk into a high enough loading state, this function iterates over all the blocks in the chunk and places the meshes of each one. For that, every chunk also stores a list of all the instanced static mesh components it needs. Then in the other direction, when a chunk moves out of a high enough loading state, this function iterates over all the instanced static mesh components of the chunk, clears all their instances, so the block meshes, returns each component to the pool and then clears the components from the chunks list. Then, last but not least, these two functions allow me to place and break single blocks. Currently I only use them to allow the player to do just that, and yay, blocks. I can finally build myself a home. Nice. I still can't help myself but think that there's something substantial missing though. The terrain just seems so barren. Some vegetation would for sure come a long way. Alright, new chunk submanager it is then. And since we're pretty familiar with the overall structure by now, I'll go through this one in a faster pace and just highlight its unique properties and inner workings. But what even makes it unique in the first place? Why not just have blocks with special meshes? Well, then you'd just have random objects floating around or clipping into the terrain, not really fitting in all that well. What I'd like to achieve is to place these objects right on the terrain. The plan would be to still have these objects be tied to the voxel grid, but allow each one to be offset. The maximum allowed offset would need to be 0.5 in every axis, since any more than that would result in the center moving out of the bounds of its voxel. With that rough plan worked out, let's get to it. For the name I'll go with Prop Manager, which I think is a really well fitting name for objects designed to complement the other structures of the game world. Most important bit first, the data structure. A prop chunk will, similar to the block chunks, need a map of the props inside the chunk. For that I'm using that memory optimized vector again, and then the instance static mesh map is basically the same. A single prop instance will need an ID for its type and an offset. Let's maybe also allow rotation of a prop though. I mean, why not? Would be pretty cool to have objects that you can place on the floor as well as on the ceiling. Now you may be looking at this and wonder how I use this vector again for the rotation and the offset this time. After all, for these I'll need floating point numbers. Well, in the f vector 3, u and 5 I added these 4 functions that allow me to store and get float vectors and rotators, which in the background just do some simple divisions and multiplications to cram the respective ranges into 32 values, since I don't need that level of precision here anyways. For the offset, this results in steps of 0.03 units or 3 centimeters, and for the rotator steps of 11 degrees, which is both plenty precise enough for this use case. With these memory savings, a single instance of a prop just requires 6 bytes to store rather than 56, a 90% reduction in memory usage. Let's now take a look at how to place one of these props in the world. I again got a very similar function to the block one here to do just that. This one just does all the necessary conversions of the input data and forwards the results to this function, which actually places the instance of the mesh specified in the prop type class. Then I have the equivalent for breaking a prop here and 2 functions to place and remove all the meshes of a chunk for when a chunk moves in or out of the required loading state to have its meshes placed. See, I said it would be quick. And at this point I wanted to improve that little house from earlier with some props, but something happened to it. Kinda looks like it drifted into an alternative dimension or something. Guess I'll have to fix that first. The saving system isn't really fleshed out yet, but let me know if you'd be interested to see how I used Unreal Engine's serialization to save the chunks. Alright, let's try this again. Yeah, much better. Let's now see what I can do with some of these props. Yeah, not entirely sure about these to be honest. I unfortunately only got vegetation models for now to experiment with, but I feel like these would do a much better job in a forest environment. Well, either way, I am quite happy with the concept, and even in this situation they do add a nice lively look to the terrain. Still need to automatically place these when generating the world though. That will be a topic for a next video. Maybe I'll also add some trees then. For this one, I again hope you were able to get some new knowledge, inspiration or just entertainment out of it, and thanks a lot for watching.